algebraically, it's if you plug in a negative x and you simplify the function when you plug in negative x, if you get back the original function, then it's an even function. Now, the reason for that, I don't know if you've ever been shown this, but essentially what happens with an even function is if you plug in 3 and you get to point 6. The idea of plugging in negative x and getting the same thing back, if you plug in a negative 3, you should also get 6 back if it's an even function, and that kind of is the whole symmetrical to the y-axis part. The fact that when you plug in a positive number and the negative version of that number, you get the same thing back, that's the symmetry with the y-axis. So to make that connection, how these two things are sort of related, that's great. If not, algebraically you do it like this, visually you do it like that. If it doesn't say, you can always type it in your calculator. Okay? And odd functions are symmetrical to the origin, which is not as clear. I would describe it differently because people don't really know as well what symmetry with the origin looks like. Can someone tell me? Remember what symmetry with the origin would look like? Or how you could describe what an odd function looks like? Like, for example, I'll show you a picture of an odd function. That's an odd degree polynomial only. This isn't talking about just polynomials. So there were always two categories. You remember getting that confused last year? There's even degree and odd degree polynomials. And that only applies to polynomials. It's somewhat related, but you might as well think of it as two different things completely. So there's polynomial, even and odd degree. That's not what we're doing. This is all functions. Nope, that's inverses. Inverses. But if I take this graph, this one is symmetrical to the origin. And the reason, what's that? Correct. Essentially, if you turn the graph upside down, it should look exactly the same. Do you see that? That's loosely and less formally speaking, that's what being symmetrical to the origin means. So you might want to write that. Looks same upside down. Andrew said a 180 degree rotation, same thing. And algebraically for this one, you also plug in negative x, but you won't get back the original function, you'd get back the negated version of the original function. And functions don't have to be either of these two things. And that's another difference between even degree and odd degree polynomials. Polynomials have to be either even degree or odd degree. There's no, they don't have a degree situation. Versus functions can be even functions, they can have that symmetry, they can be odd functions, they can have the secondary symmetry, or they might have nothing at all, which means they're not an even function and they're not an odd function. They're neither. You can't be neither if you're talking about degree. Does that make sense? Okay? So, this should be fairly quick. You did this primarily up top are the types of examples you did last year. We're going to expand on these because these are coincidentally all polynomials, right? And again, I'm going to point out that this whole concept isn't just for polynomial functions. It's for radical functions and rational functions, exponential functions. It's for all different kinds of functions. So we're going to look at an example of each of those after we get these polynomial ones done. So we'll do them first algebraically. We'll do them all algebraically. So no matter what you're testing for it, you plug in negative x. And when you plug in negative x, make sure you keep it in parentheses so you don't forget to square the negative. And on this one, you get x squared minus 5. And then you compare it to the original. If it's the same, it's even. If it's entirely opposite, meaning if it's negated, it's odd. And if it's some combo, then it's neither. So, Carolina, what would you say? Even. Yep. Same as the original. This is even. You should know that this is just a parent graph of a parabola shifted down 5 units. The parabola parent graph is obviously symmetrical with the y-axis. If you shift it down 5 units, it's also symmetrical to the y-axis. So you can see it visually, you can see it algebraically. Any questions? Okay? On B, always plug in negative x. What is negative x when you cube it? Negative what? Negative x cubed. Now we just lose the parentheses. Minus 1. So is that exactly the same as the original? No. Is that a negated version of the original? No. Here's what if this is the original, a negated version of it is like putting a negative out in front, which would have been negative x cubed plus 1, and that's not what we have. So this one is neither. Here's this one visually. Kind of looks like that one I did show you, but do you see how this one has a y-intercept of negative 1? If I flip it upside down, it has a y-intercept of positive 1, so it's not exactly the same. Does that make sense? Okay? Next. There's 2 places to plug negative x in here. So negative x cubed again becomes negative x cubed without the parentheses, and we would typically just put that negative out in front. We wouldn't keep it between the 5 and the x because it would look like minus. And then the double negative makes plus x compared to the original. Is it the same? Is it a negated version of the original? Yes. Odd. I think we get it, right? Okay, so then I'm going to skip these next 3 and give you examples that are not polynomials. And because you have only done polynomials, I can almost guarantee your judgment is going to be off regarding even or odd. So if I plug in negative x, I get root negative x minus 5. Is that the same as the original? No. Okay, that's clear. Is it the opposite of the original? No. What would, you're right, it's not. But what would the opposite version of that look like, you think? Root negative x both sides? Any other guesses? Under a radical? Like this? Yes. 9. Take off the radical and square. Right. So with polynomials, and you guys know this because you've been doing it for 3 years now, if you take a polynomial and negate it, because you distribute, right, all the signs are flip-flop. So that's what Connor did, right? So you can't really blame him because that's what he has been used to doing. But when you negate a radical, when you just put a negative out in front, you don't distribute that through, right? You all know that. You don't distribute a negative through into a parentheses. You don't distribute through it. So a negative version of this would look like that. So you know. Okay? This one was neither, yep. So I have the simplified version up there. Hopefully everybody had that same thing. Madeline, what do you think? Even, odd, or neither? Odd. Does everyone agree with that? That's correct. So if you're taking this and negating it, you would just put a negative out in front, and there's not much to do with it other than just let it sit out in front, and that's exactly what this looks like. Now, obviously you guys have your calculator, so if it says to do something like this algebraically, you have to show your work, but you also can grab some confirmation by just plugging it into your calculator and seeing if it does look the same right side up as it does upside down. So this one, I have no idea what this graph is going to look like, but I'm pretty positive it's going to be the same right side up as it is upside down. So here it is. Yes? And then if you flip it, same thing. Okie doke. Rationals are another kind of thing we have to talk about. What would a negated version of this look like? If you took x plus 3 over x minus 4 and put a negative in front of it and then simplified, what could this look like? And there's a couple different options that would qualify. Oh, we just missed the most important part of the lesson, but there's a video. Connor? Hold on. Thoughts on that? I'm going to tell you right now it's not correct. And who can help explain why what Connor did there is not a correct version? Actually, let me do this. There are other ways to do it, but I want to focus on why Connor's is not right. Think about this. That's 5, right? 5 over 1. So what is the opposite of 5? Negative 5. No. Opposite in math does not mean reciprocal. Opposite means negative. So the opposite of 6 is negative 6. The opposite of 5 is negative 5. So what is the opposite of 5? Negative 5. So if we were following Connor's, what he did, we would make this negative 2 minus 3 over negative 5 plus 4. Does that give you the opposite, negative 5? No, it gives you what? The same thing. Doesn't it give you negative 5 over negative 1, which is still 5? Why? Why is negating through the numerator and through the denominator a bad move? Connor technically multiplied by negative over negative, which is just 1. So by negating both the numerator and the denominator, you essentially just multiplied by 1. You changed the appearance, but you did not change the value. Do you remember at all in rationals last year, you'd simplify something, and if you checked your answer, every single sign in the entire fraction was opposite, and you thought you were wrong, but you were really also correct, and that just kind of depended on the order you did things. So if every single sign is different, it's still the same number. If there's a negative in front of a fraction, you can either negate the numerator and leave the denominator alone, or you can leave the numerator alone and negate the denominator. What a lot of you kept mentioning is, don't you just flip it? If you were going to leave the numerator alone and negate the denominator, yes, you can negate x minus 4 by just flipping it to 4 minus x. So those are 3 versions of what would be the opposite of this fraction. Does that make sense? Okay, so again, it's a little bit more challenging than just finding the opposite of a polynomial where we switch every sign and life is easy. You got to think a little bit more about it. So if we actually test H to see if any of these three potential odd versions come up, you don't have to really review even, because even will look exactly the same. Or, actually what Connor gave me would be technically an even outcome, because he flipped everything. So plug in negative x plus 3 over negative x minus 4. If you, that's simplified. So if I compare that to the original, does it fit any of these versions? No. Because I only really negated a piece within the numerator and a piece within the denominator. It's neither. Rather than just negating just the numerator, just the denominator. And again, you've got to show algebraic work. That doesn't, when it says to do this algebraically, that doesn't mean you can't use your calculator to look, to also like firm up your belief. Okay, then in the next one, if I plug in negative x, compare it to the original. What? Correct. Can anyone think of an example of a rational that would be odd? Over. I said rational, so over what?
Over x.
Let's see, f of negative x is, I don't think so. I think this is going to be even. Maybe not, hold on. I'm not sold. It's going to be negative x cubed plus x. No, it's not, because it negates the numerator and the denominator, which means it's actually an even. You follow?
Yeah.
You know why it's even? Just for the record. That numerator is factorable into x and then x squared minus 1. And then the x over the x is going to cancel. And it's just an even polynomial. Something like, I don't know, 1 over 2x. If you plug in negative x for that, you'll get 1 over 2 times negative x, which is just 1 over negative 2x. That's a negative version. So something, I'm sure there's more complicated ones, but that's just like a simple one I can think of off the top of my head. Okay, so you are going to do, wow, look at me, 15 I got it stacked today. I've got a new system, so I don't forget. Odds on this, you should probably be able to finish it by the end of the period. Or come 40 yards.